What's up, everybody? Welcome back. Moving on to another question. We have a couple of linear inequalities to solve. So let's start off with this one here. So what you want to do with linear inequalities is you want to bring all the variables to one side, all the numbers to the other. So let's start off by expanding, distributing this 4 inside the bracket. So 4 times 2 is 8. 4 times negative 3x is minus 12x, less than or equal to 2x minus 6. Now, as I mentioned in the lecture videos, I like to bring all of the variables over in a way where the x's will be positive. So notice if we bring this negative 12x over, we'll have 2x plus 12x, which would give us positive 14x. So I'm going to bring this negative 12x over, and then I'm going to bring this negative 6 over to the left side. So I'll have 8 plus 6 less than or equal to 2x plus 12x. 8 plus 6 is 14. Less than or equal to 2x plus 14x, or 2x plus 12x, which is 14x. Divide both sides by 14. And the reason why I want to bring it over so it's positive, so when we divide and isolate for that x, we don't have to flip this sign. Because whenever you divide by a negative number, you have to remember to flip this sign as well. So it just gives us one less thing to keep track of. And we end up getting this solution. X is greater than or equal to 1. And you can also show this in set notation, so we can say x is an element from 1 to infinity, right? X is greater than 1 is basically all the numbers from 1 to infinity. It's also inclusive of the 1, so this is a square bracket, not a circle bracket. And we can also show this on a number line. So if this is 0 and this is 1 here, this would be a closed dot, a closed circle, right? Filled in circle because it's inclusive of the 1. And it's just all of the x values that are greater than 1. Moving on to this inequality, notice how this is a double inequality. So as I mentioned before, when we're working with double inequalities, you want to look at this left inequality on its own, then this right inequality on its own, and then combine them at the end. Now, before we do that though, I'm going to just simplify the middle expression a little bit. So I'm going to distribute the 2 inside the brackets. So we'll have 8x plus 18 minus 5x minus 35. And this is still less than or equal to 64. All right, so I'll have 28 less than or equal to 8x minus 5x. That gives us 3x. 18 minus 35, that gives us minus 17. And this is still less than or equal to 64. And now that we're at this point, what I'm going to do is I'm going to split up these inequalities. So I'm going to work first with 28 being less than or equal to 3x minus 17. So if I bring this 17 over, this negative 17 over, 28 plus 17 gives us 45. Divide both sides by 3 to isolate for the x, so we'll have x is greater than or equal to 15. Right, so that's the solution for this inequality. And then moving over to this side, we got 3x minus 17 is less than or equal to 64. So we got 3x, bring the negative 17 over, 64 plus 17 gives us 81. Divide both sides by 3, x is less than or equal to 27. So that is the other solution. And now what we have to do is we have to look at both of these solutions together and see if they make sense. Well, x has to be greater than or equal to 15, and x has to be less than or equal to 27. And that gives us a possible solution. That means x has to be in between 15 and 27, inclusive of those. So the answer to this double inequality is this here. Remember, at this point, you have to combine the inequalities at the end because it was given as a double inequality initially. And if you want to show this in set notation, basically it would just be square brackets 15 and 27, right? X is an element of that, right? Because it's inclusive of 15 and 27, hence why we have the square brackets. If it wasn't inclusive, so if it was just x is greater than 15 and less than 27, these would be circle brackets. And if we want to show this on a number line, actually, you know what? Let me put the 0 here. So let's say this is 15, this is 27. So we would fill those dots in at 15 and 27 because it's inclusive of them. And just basically all the x values in between that. Right, so multiple ways to show this solution. Interval notation, set notation, number line. Here, what I did first was I simplified the middle term to 3x minus 17. So then when we split it up into the two inequalities, we don't have to simplify it again, versus if we split it up, both of them at the top. Right? So solve the inequalities, get to this point, make sure that they make sense and you can combine them. Sometimes they won't make sense. So for example, let's say this one was x is less than or equal to 15 and this one is x is greater than or equal to 27. Well, combining those, there's no x values that's going to satisfy both of them, right? So then there would be no solution. But in this case, x is greater than or equal to 15 has to be less than or equal to 27. There is a possible solution in between 15 and 27.